Hello all. In this session, we'll discuss about inheritance. Inheritance is one of the core features of object-oriented programming. It's a programming procedure that allows you to reuse code by referencing the behaviors and data of an object. In other words, a class that inherits from another class shares all the attributes and methods of the referenced class. An inherited class is called a subclass or child class or of the class it inherits from, and the class being inherited is called either a parent class, superclass, or base class. Here you can see definition. Okay. This makes it easy to create new classes that are slight variations of the existing ones. If you see the example, parent class. The parent class defines a method called greet. When you create an instance of the parent class and call greet, it will print hi from parent. Child class. This child class is a subclass of parent. Subclass of parent. It does not define any new methods or attributes. The pass statement is used here to indicate that the child class does not have any special implementation. Since child is a subclass of parent, it inherits all the methods and attributes from parent. This means that even though child does not have its own greet method, it can still access the greet method from parent. Then here if you see, when you create an instance of child, that means like this, the object C is of type child, this one. But since it inherits from parent, it can use the greet method from the parent class, and thus I from parent will be printed. What is the key concept here in this example? Inheritance without overriding. If a subclass does not override a method, it inherits the method as is from its parent class. That is a greet method, which is having message I from parent. We'll run this program in Visual Studio Code. Save it, run. Yeah, you can see I from parent got printed. Then we will see overriding methods. That means child classes can override methods from the parent class to customize behavior. Okay, this is the code. Here if you see class parent, this class, it has one method greet which prints hello from parent. Then one more class child. This is the definition of the child class. Here child inherit the properties from parent, but it overrides the greet method, meaning it provides its own version that replaces the parent version when called from a child object. This is the child object creation. C equal to child. Then from this object we are calling greet method. Okay. C dot greet call the overridden greet method in the child class because child is having its own version. So what will be printed? Hello from child will be printed. What is the key concept here? We do have inheritance and method overriding. Inheritance, child inherits the properties from parent, so it has access to all non-private members of the parent unless they are overridden. Then method overriding. The child class redefines the greet method, so its version is used instead of the one in parent. So we have two key concepts. One is inheritance and another one is method overriding. This will check now. This is the code. So what outcome has to come? It has to give the outcome as hello from child. Okay, we'll save, then we'll run. Yeah, hello from child. Okay, now we will see the another one using super. You can use super to call methods from the parent class which is especially useful when extending or customizing inherited methods. If you see, this is the code. Class animal, then class dog. Here we have two classes, the animal class and dog class. Animal class, this is the parent class or base class. We do have init method. This is the constructor method. It gets called when you create an instance of the class. It takes self, the instance of the class, and name as arguments and assigns the value of name to the instance variable. That means self dot name equal to name. And it also has speak method. This is a simple method that prints a message indicating that the animal makes a sound. The self dot name refers to the name of the animal passed when an instance is created. Then we do have a dog class. This is a subclass or derived class or child class of the animal class. It inherits from the animal. You need to write like this: class dog brackets open. Inside you need to write animal. That means this dog class inherit the properties from animal. When it inherits from animal, which means it has all of the functionality of the animal class, but can also have its own additional features or modified behavior like this. Here also you can see init method. This is a constructor accepts name and breed as arguments. The super, this is a inbuilt function, super underscore underscore init name. This particular statement calls the constructor of the parent class animal to initialize the name. Then it initializes the breed specific to the dog class. It also having speak method. The speak method in the dog class overrides the one of the animal class. If you see, animal class is also having speak method. Dog class also having same name. And if you see this particular definition of the speak, it first calls super.speak, which calls the parent class speak method, this one, to print the message for a generic animal sound. Then it adds a specific message for the dog barking. Okay. Now if you see this one, d equal to dog, when we write like this, it creates an instance of the dog class, d equal to dog. For this, we are creating instance. The name of the dog is Rex and the breed is Labrador. Okay. D dot speak. It calls the speak method of the dog class. This one. It first invokes the speak method from the animal class due to super dot speak and then prints this particular statement. So if you observe the complete code till here, what are the key concepts? We do have inheritance, method overriding, super inbuilt function call. So summary, the dog class inherits from animal. This means the dog can use methods and properties from animal and can override them if necessary. Then method overriding. In the dog class, the speak method override the one in the animal. This one. And what is the another key concept? Super inbuilt function. We already knew super is used to call methods or constructors from the parent class animal within a subclass dog. Okay. So for this, what is the output we expect? Dog name is Rex. First it print Rex makes a sound and then Rex barks. We will run this code and see the result. Save, run. Yeah, you can see the result. Rex makes a sound. Rex barks. Rex makes a sound. Rex barks. Now we will see what are the various types of inheritance. Type, description. Single, one child inherits from one parent. Multiple, one child inherits from multiple parents. Multi-level, child, parent, grandparent. Hierarchical, multiple children inherit from one parent. Hybrid, combination of multiple types. We'll see the example for multiple inheritance. Class A has a method greet that prints hello from A. Class B also has a method greet that prints hello from B. Class C inheriting from A and B. Okay, we do have instruction pass in class C. This means that C will have access to the methods and attributes of both classes A and B. However, class C does not define its own greet method. It will inherit the greet method from either class A or class B depending on the method resolution order MRO. Now, creating an instance of C and calling greet function. So this is the instruction for creating an instance, and the greet method is called on C. Since C inherits from both A and B, Python looks at the MRO to determine which greet method to use, this one or this one. Thus, Python will use the greet method from class A, this one. Why? Because in the code instructions, first class definition for class A, that's the reason. And this print statement will be printed hello from A. We'll see this outcome. This is the code. Save, run. Yeah, you can see hello from A. Now we'll see the example for multi-level inheritance. Here if you see the class person, class employee, class manager, we do have three classes. Person is the base class. It stores a name and prints it in display. Then employee inherits from person. It adds a new attribute, employee ID. It overrides display but still calls super inbuilt function super.display to reuse the person display logic. If you come to manager, manager inherits from employee, which already inherits from person. It adds a new attribute department. Again, it overrides display and calls super.display to include everything from the parent classes. This particular instruction creates a manager object with name, alias, employee ID E1 to 3, department HR. Then one more instruction m.display calls the manager version of the display, this one, which calls employee display because super display, right? It goes to employee display, which calls again person.display, this one. This is a chain and prints name, alias, then prints employee ID E1 to 3, then manager display prints department HR. So what is the final output? Name, alias, employee ID E1 to 3 and department HR. So what are the key concepts here? Inheritance. Each class inherits from its parent and extends functionality. Super inbuilt function used to call methods from the parent class. Method overriding. Subclasses redefine display. This is the employee subclass, right? Display. We have redefined to include more info while preserving base behavior using super inbuilt function. We'll run this code. Save, run. Yeah, we have got a result. Name, alias, employee ID E1 to 3, department HR. Now we'll see hierarchical inheritance. Here in this example, we have three classes: animal, dog, cat. Animal is the base class. It stores a name. Init method, this is the constructor. When you create an instance of animal, it takes a name and stores it in self.name. Then speak method provides a generic sound of any animal. Then the dog class, it inherits from animal. It overrides the speak method to provide a dog specific sound barks. Then we have a class cat. It inherits from animal again. It overrides the speak method to provide a cat specific sound meow. Then this particular statement creates a dog object with the name Jello. This particular statement creates a cat object with the name Whiskers. After that, we have a statement d.speak. It calls dog's version of the speak. This one. Then one more function c.speak. It calls the cat version of the speak. So what will be printed? D dot speak, it goes here, it prints jello barks. Then C dot speak related to cat, it goes here, it prints whiskers mouse. So in this example, if you see, what are the key concepts? Inheritance, dog and cat inherit from animal. Method overriding, both dog and cat redefine speak method to provide specific behavior. Okay. Polymorphism, speak is called the same way on both objects, but each gives a different result based on the class. We'll run this code. File, save, file, run. Yeah, you can see the result, jello barks, whiskers mouse. Okay. Now we'll discuss about what is hybrid inheritance. Hybrid inheritance is a combination of two or more types of inheritance. You might combine multiple and multi-level inheritance in one hierarchy. It can get complex, and Python uses MRO, method resolution order, to manage it. If you see the diagram, there is a class A, class B, class C, class D. B and C classes are inherited from A. D class inherited from B and C. Class D inherits from both B and C. Class B and C inherit from A. So it's a mix of multiple and hierarchical inheritance, hence hybrid. If you see the code, class A, this is a base class with a show method. Class B inherits from A. B overrides A show. Class C inherits from A. C also overrides A show. Again, class D inherits from both B and C. D defines its own show method. And again, we do have a super inbuilt function call super.show to call the next method in the method resolution order. Python uses C3 linearization algorithm to determine the order in which classes are searched for the methods. Here, the MRO of class D, B, C is when super.show is called in D, Python goes to the next class in the MRO, which is B, because B definition is first compared to C class, this one. So the print statement, this is class B, will be printed. Okay. So if you see this code, so if you see D, B, C, A, so super.show in class D calls the method from class B. Now if you see, we have created object for the class D, and we have initiated the show call. So object dot show calls D dot show, this one. D show, this one, prints very first statement, print statement, this is class D. It will be printed. And then next statement, super dot show. It calls method from B due to MRO. We discussed already. So what is the print statement in B? This is class B. So what are the final outcome? It will, this print statement will be printed first, this is class D, and the next print statement, this is class B. These two will be printed. So what are the key concepts? Multiple inheritance, class D inherits from both B and C. Method overriding, each class overrides. So method, we do have a call super inbuilt function, calls the next method in the MRO. We'll run this code. Save, run. This is class D. This is class B. This one and this one. Okay. So, in summary, the benefits of inheritance are code reuse, easier maintenance, clear hierarchy, extensibility. That's all for this video.